All right, first things first. I've sent it out to you guys. It's been up since right after class on Monday and stuff about what's our plans for this week. And you know test was coming if you pay attention to your syllabus and stuff. And here it is. And I've gotten lots of emails that I decided not even to respond to because they're all saying the same thing, which is, well, I've got class on Fridays at this particular time, or I've got to do something, go someplace, whatever the case may be. Now, the Friday class is the review session thing that I set up for you guys all week long, and we encourage you guys to go, but it's not mandatory. This is what I plan on doing on Friday. On Friday at 12:30 in here, I will be collecting all the homework sets. Now, if you can't come or whatever, that's okay, but you have to turn it in early, because and that means bring it to me in my office, or slide it under my office door, or something like that, or give to the departmental secretary to put in my mailbox, whatever the case may be, but you got to get it to me before 12:30. Why? What I plan on doing at the review session is actually doing this homework set for you guys and talking about the test. I do plan on recording the review session like I'm recording class. So I always record, when it's a problem session that you guys are asking Andrew questions and stuff like that on web work, on the Hawk system work or anything like that, I don't record that because I'm basically answering individual questions and stuff. But when it comes to actually the homework where I'm going over an entire homework set to prepare you guys for your test, then I'm going to record that for everybody. For those few individuals that feel like this is not kind of being unfair for them, well, the goal is, if you got something to do, rearrange your schedule, because this is kind of important. This is called college. But if you do have a class at the same time or something like that, well, that's understandable. Math is still more important than anything, but still a little bit. Some teachers throw a fit about you guys missing out on somebody else's class. But that being said, I am going to record this thing so you guys so you can study for it all weekend long, because your test is going to be when? Monday. What is it on? Chapter 1 and Chapter 2 material. Well, what kind of questions am I going to ask? Well, here it is. Now, here's my problem here. I put two of them up here, and I can tell you the reason why. I put this thing up here, and I didn't realize that the last page didn't print out or didn't scan in. So I made the last page a bonus question page. So here it is. You can get bonus questions on this thing. So I'm going to grade it like out of 115 points or something like that. So you can get extra bonus on these things. Because what happened was the quadratic questions, they were over here and they didn't actually show up on my thing. So I made two sets now. Here's the homework number one, and I'm going to make 3 more questions that are bonus questions. So just basically print this thing out and staple it to the other part, and we'll grade it all together, and I'll make them bonus questions so you can get more than 100 on this thing. Now, here is how we're trying to incorporate a standard traditional test with the Hawk system. Doing this continuous homework problems and stuff like that. Well, there's going to be 2 things. You're going to have, 3 things. You got my homework set to do. That's one thing. So I'm trying to prepare you for the test. There is the web test already up for you guys. And we decided to do it just like you guys do the pre-section quizzes. You have 3 attempts, and you don't get any more. And the web test has to be done before Monday at 1:55 p.m. So you can get all weekend long. You got the rest of the week, the weekend, and also up including the day of Monday. But after 1:55, it shuts off, because we're going to put this into our grade book and put this with the test grade, which will be, like I said, you'll take the traditional test on Monday. And so these are the components that are making up your test. There's 2 parts. There's the web test component, and there's the other test. And they go in as separate grades in your grade book. But the big one is going to be the traditional test. That's a big part of your grade. Yes, ma'am. It's in here. Let me show you once again. Up here at the top, on there, Math 1100 review sessions based upon the week's work will be every Friday from 12:30 to 1:45 in here. It's always been in here. We've had, 3 or 4 review sessions already in here. So if you haven't been, shame on you. You should come, because we're trying to help you guys out and stuff. It's another way of getting you people into the review sessions, because this is why I kind of designed those things for. Okay? But as I was mentioning, in case you have a problem and you cannot come to Friday's review session at 12:30 in here, well, you can turn it in early. And then, so you can turn it in anytime. Just make sure you get it to me or slide it under my office door or give it to the departmental secretary to put in my mailbox or whatever. But the reason why 12:30 is I'm going to go over this thing. And so if you got it, just hold on to it, bring it to the review session, which is what I want. And I will record this thing and I will go over the whole thing for you guys. So you've got something to study over the weekend. Because my goal here is this. Let me make it very clear to you guys. Because of the difference between, traditional test and you've got all this computer stuff that you've been doing, because you guys are 21st century students these days, there's a little bit of a disconnect. So I'm trying to make a real connect between what the test is going to look like. I'm signaling to you guys what kind of questions I'm going to put on the test. And here they are. I've made part of it multiple choice. The rest of it is free response. I'm trying to mimic this thing as what the test is going to look like, which is what your cumulative final exam is going to look like. Yes, ma'am. Well, I would recommend maybe you want to take it. You got 3 opportunities. You can try to take it once and get your best grade that you can. And if you have a problem, find out what kind of problem questions that you're having a problem on and bring it here or seek other help. You can come by and see me personally. That's great. You can see Andrew as well. And also you got SI sessions. You got Fretwell 315. You got lots of different resources to go get help to make sure you do it, because what you really should get is you only got 3 attempts. You got to get 100 on this thing to make an A on that part of it. My test is going to be, like I said, the traditional test. Paper, pencil, bring your calculator, show your work on the test, that type of thing. Yes, ma'am. No, they're not. If you check on your syllabus, the in-class tests are weighted a lot more. The web tests are graded more like a homework type thing here. But it's still an important grade. You don't want to miss out on it, because you miss out too many points. You shot your A, you killed most of your B, and you're dwindling all down the list there. Yes, ma'am. Okay, no, they're not graded. They're not weighted the same. The in-class tests are the big grades. And actually, out of all your grades, what's the most important grade? Cumulative final exam set up by the math department. And what follows behind that? The in-class test, which is on Monday. Other question? Yes, sir. Well, let's see here. I think about 25 to 30. I haven't finished making it up yet. That's what weekends are for. So between 25 and 30. So I kid my students about this, but it's really the truth. When's your test? When do you think I'm making this thing really up? Sunday night. Yeah, that's typically what I do, and go get it printed up early in the morning, and so you guys will have it. So I haven't finished making it up yet, honestly. But I'm looking at somewhere between 25 and 30 questions. So to judge this, look at the size of this homework set and see how long it takes you to do this particular homework set. Because this is the size that I'm looking at for a test. Maybe a little bit smaller than this, because this is take-home homework type stuff, but this will give you a good idea of what the test is going to look like, and that's kind of the whole goal. That, and look at the questions and how I worded the questions. Other questions? Yeah. Now, when you take the test on test days, I would put you anywhere I want you to put out. Typically, with this number of students, I'm going to see if I can put a seat between you and your neighbor, kind of separate you out a little bit and stuff like that. Because, I've got you, in terms of the test and being documented that you're actually here and stuff, it's pretty obvious you'll be here because you're turning in your test. So I've got you naming down, so I don't care actually where you sit at during the test and stuff. I'll put you in spots, I'll spread you out a little bit and stuff like that. So the seating chart is off in terms of test days and stuff. But to make sure, because this, again, is a university directive as well as the math department directive, we have an attendance policy here. You've got to come at the beginning of class, and you've got to stay for the full class, and that's Andrew's job in terms of collecting the data. Yeah. If you finish the test early, you can leave. Can you leave early during my awesome lectures? Oh, hell no. So does that make sense, though, in terms of the understanding the test and stuff? And again, the whole goal here is this homework set, as painful as it is for some of you guys to get in, I'm really trying to help you guys out. I'm telling you what kind of questions I'm going to put on the test and how I'm going to word these questions. The beauty of math, I change one number, you got to do the whole problem all over again. So Focus on this and making sure you're getting these examples that I've given you on the homework set, making sure you're mastering them. Because if you can master this homework set, you should have no problems at all in mastering my test. So I'm really trying to help you guys out, okay? So, all right, let's continue on. Now, today's lecture is we're finishing up the quadratic stuff, the rational stuff from section 2.5, and we're moving on into the last section, which is radical expressions and functions, section 2.6. 2.6 is the last stuff that's on the test. And so this is all the material that we went through last time. And if you remember, we talked about, rational expression and having domain issues on those things. That there's certain points you can't divide by 0, so in terms of the domain, it's typically going to be all real numbers except where the bottom is equal to 0. Those are the points you have to omit. But if we go over here, we were working on actually simplifying rational expressions. Rational expressions is a fancy word for fractions. So this was the last problem that I actually went into here. So I want to pick it up with problem number 10. All right. So problem number 10 states this. I have x plus 2 divided by x minus 2 plus x minus 6 divided by x plus 4 plus 4 divided by x squared plus 2x minus 8 is equal to what? And they want you to simplify this thing. And we're talking about fractions here, so basically I'm just adding a bunch of fractions. But to be able to add fractions, you've got to have a common denominator. So to figure out the common denominator, analyze your denominator. So this is x plus 2 over x minus 2. So x minus 2 is my denominator. Plus x minus 6 over x plus 4. So x plus 4 is my denominator. Plus 4 divided by, now what about this x squared plus 2x minus 8? I want to figure out it from a common denominator perspective, so what am I going to do? I'm going to factor. How does x squared plus 2x minus 8 factor? Good. X squared is x and x. What times what is 8 that differs by 2? 4 and 2. And since there's a minus, they're different signs. Since the middle term's a plus, the big number is going to be a plus. It'll be x plus 4, and the small number, x minus 2, will be negative. Yes?
Why couldn't you just pull out an x?
Why couldn't I just pull out an x out of this thing? And the reason why is not each term has an x. If this was the case, just x squared plus 2x, I could just pull out the x. That minus 8 doesn't have an x in it, so I can't factor it out of the whole thing. The whole purpose of factoring is to turn addition and subtraction into multiplication.
So if you had a 2x squared plus 2x minus 8,
Then you could pull out a 2, because I couldn't pull out an x, because there's not an x in each term. But if it was 2x squared plus 2x minus 8, I do have a 2 in common. I could have factored that whole thing out, absolutely. But they got to be in common to be able to factor it out. But this was a trinomial, otherwise known as a quadratic, which means we want to traditionally do an anti-full thing. But if there is a number in common, you want to first pull that sucker out, factor it out. All right, so now, let's talk about your common denominator. So now it's 3 fractions here, so I'm going to put my little line here so don't get confused from the last problem here. Here we go. Now, what is my common denominator? To get a common denominator, I'm going to analyze each factor in my denominators. I've got an x minus 2, so my common denominator has to have an x minus 2. I've got an x plus 4, so now my common denominator has to have an x plus 4. And this thing has anything extra? It's already got the x plus 4, it's already got the x minus 2, and there's nothing else extra, so this is the common denominator between all 3 terms. Does that make sense? If there was something extra, like a 2 out here, then I would have to put the 2 in my common denominator. Your least common denominator is the biggest denominator that all the other denominators fit inside of. Does that make sense? So, my common denominator would be x minus 2 times x plus 4, so I'm going to put it under each one of these guys. X minus 2 times x plus 4, x minus 2 times x plus 4. And here we go. What did you do to this denominator to actually get the common denominator? I multiply by x plus 4. So what I do to the bottom, I got to do to the top. What I do to the denominator, I do to the numerator to make it fair. So this would be x plus 2, my original numerator, times x plus 4. Now what did I do to this denominator? x plus 4, to get the common denominator of x plus 4 times x minus 2. I multiply by x minus 2, so I got to multiply the top by x minus 2. That leaves me with that original numerator, x minus 6, times the new part of the numerator, x minus 2. And then last, what did I do to this denominator, x plus 4 times x minus 2, to get the common denominator of x plus 4 times x minus 2? Nothing. So it's the same denominator, right? So I actually have to do nothing to the numerator and leave the numerator alone, to the 4. Now, once you get your common denominator, you write it as one big common denominator, x minus 2 times x plus 4, and all your action goes in the numerator. This is x plus 2 times x plus 4, plus x minus 6 times x minus 2, plus 4. So there's almost your answer. But now all you got to do is clean it up. How do I clean this stuff up? Well, I've got, multiple terms here. I want to combine like terms to be able to get a nice, decent numerator out of this guy. To be able to do that, I need to clean up this first term, which is x plus 2 times x plus 4. How do I clean this guy up when I want to combine like term stuff? I'm going to fold it back out. So this would be x squared plus 4x plus 2, and then 2x, and then 2 times 4 is 8. And then I'm going to add that. I'll clean it up in just a little bit. I'm just going to see you folding out. I'm going to have to fold this thing out as well. X minus 6 times x minus 2. Folding it out, x times x is an x squared. And x times a minus 2 is a minus 2x. A minus 2 times an x is a minus 6x. And then a minus 2 times a minus 2, minus 6 times a minus 2 is a plus 12. And then I got this last term, which I'm just going to recopy, plus 4. So my common denominator is still the same, x minus 2 times x plus 4. But what about your numerators? Combine like terms. What is x squared plus x squared? 2x squared. What is 4x plus 2x, 6x, minus 2x, minus 6x? Let's try that again. 4x plus 2x is 6x, minus 2x is 4x, minus 6x is minus 2x. And then what about your constants? What is 8 plus 12? 20 plus 4? 24. Just watch the careless errors on adding up stuff. Does that make sense? Now, the last thing you typically want to do with this after you combine like terms is, if there's anything in common, try to factor it out. Because you want to factor just to see if there's a term in the numerator and denominator that are the same. What can you factor out of this entire numerator? I can factor out the 2 because the 2 is in common in each part. So that'll be 2 times, what's left? X squared minus x plus what? 12. When you factor out, you're dividing out. Over x minus 2 times x plus 4. One last thing about this problem is this. If you've got a quadratic, and that's what's in your numerator, try to factor the quadratic just to see if anything's going to cancel. But in this problem, does the quadratic part, the x squared minus x plus 12 factor? No. Because here's your problem. You got plus 12. What are the factors that make 12? Well, 1 and 12, 2 and 6, and 4 and 3. Which one of those add up to be negative 1? None of them add up to be negative 1 when I combine these guys, so this thing does not factor. So this is my solution in terms of simplifying. If I ask you this on the test, what are the domain restrictions on this problem? What would you tell me? Right. It's domain restrictions are where the denominator can't be equal to 0 at. So that would be where x minus 2 is equal to 0 and x plus 4 equals 0, making x not equal to 2 and x not equal to negative 4. And in terms of interval notation for the domain, that would be between negative infinity to negative 4, union negative 4 to 2, union 2 to infinity. And how I got that was I took my number line and took away -4 and took away 2, and it's everybody else. So if you ever get in trouble, draw a number line, because the number line imitates what the interval notation is. Question? Okay. Does that make sense, though? Questions? All right, so how can we make these things even worse? Oh, well, let's try it out. Something called complex rational expressions. Well, you know you're in trouble when they throw the word complex in the middle of this thing. So complex rational expressions. You got fractions being added to fractions in the numerator and fractions being added or subtracted to fractions in the denominator. You got fractions in the numerator, fractions in the denominator of a big old fraction. Fractions of fractions. That's what they call complex fractions. All right. So to do this problem, you do one step at a time. That's all you got to do. Now, just to remind you, this is division. So I'm going to try to combine my fractions in the numerator to turn it into one big fraction. I'm going to combine the fractions in the denominator to turn it into one big fraction. And because it's division, how do I clean up a fraction divided by a fraction? What do I do? Multiply by the reciprocal, flip and multiply, invert and multiply, whatever your teacher taught you guys the name of it. But you pretty much flip and multiply by the reciprocal. So first thing I'm going to do is leave my big division here, and I'm going to work on the numerator fractions. I'm going to focus on a common denominator. Look at your denominators. I got 1 over x minus 3 halves. What is your common denominator? 2x. Just put the two denominators together. 2x and 2x. What did you do to the x to get the common denominator 2x? You multiply by 2, so you got to multiply the top by 2. So 2 times 1 is 2. The operation stays the same, it's minus. What did I do to this 2 to get the common denominator of 2x? I multiply by x. So I multiply the numerator, 3 times x, and I get 3x. Does that make sense? And then I can write it as one big common denominator. This would be all over 2x, and all your action goes in the numerator. It is 2 minus 3x divided by 2x. Now, at the same time, once I clean up the numerator there, I'm going to focus on the denominator. The denominator fractions. I got 1 over x plus 3 over 4. What would your common denominator be of these two guys? 4x. Just put them together. What did I do to x to get a 4x? I multiply by 4. So what I do to the bottom, I got to do to the top. And 4 times 1 is 4. What did I do to 4 to get 4x? What do I have to do? Multiply by x. So I got to multiply the top by x. What does that give me in the numerator? 3x. Now write it as one big common denominator thing. You get 4 plus 3x all over 4x, because all your action goes in numerator. So far, so good. So it's just working fractions in the numerator, fraction in the denominator. But now you got pretty much one more big move. What do you do when you have a fraction divided by a fraction? Invert multiply by the reciprocal of the guy in the denominator. So this would be 2 minus 3x divided by 2x. Instead of divide, we hit times, and I invert multiply. 4x divided by 4 plus 3x. And put parentheses around these binomial terms there. Because only under strict multiplication division do things cancel. What cancels? Well, let's see here. I've got 2 minus 3x times 4x divided by 2x. And over here I got divided by 4 plus 3x. Well, strict multiplication division, things cancel. What cancels here? The x's cancel. What else cancels? 2 goes into 4 how many times? 2 times. So I get my final solution of 2 times the entire term 2 minus 3x divided by 4 plus 3x. And there is my solution. Does that make sense? But I got one more question about this particular problem for you guys. What are my domain restrictions? Now, it's a game, so please treat it as a game. To figure out the domain restrictions, you got to go back and look at all the different fractions you have, because you got This thing's has huge fractions. This is called complex fractions. You got fractions all over the place. The big deal is this. You're not allowed to divide by what number? 0. So I have to omit any x's that's going to make me divide by 0. So look at your original fractions. Look at the ones at the top. I got 1 over x minus 3 over 2. What can x not be equal to in the original problem? You're looking at it, is what I'm looking for. What x cannot be equal to? Oh, you can have 2 there. 1/2 minus 3/2 is like -1. What? You can't divide by what number? 0. So x can't be what in this problem? 0. So that's one domain restriction. X cannot be equal to 0. And on the bottom, I got the same problem. I got x as the denominator on the bottom. X can't be 0, right? All right, so over here, this is still, we have the same restrictions. X can't be 0 because that would make me divide by 0. This has the same restrictions. X cannot be 0. But then I go to my final answer, and I cleaned it up because that part canceled. That's awesome. But I have a new denominator. You see them? The answer has 4 plus 3x in the denominator. So to figure out the other domain restriction, I take my new denominator, which is 4 plus 3x. I'm going to set that equal to 0, and I'm going to solve. I'm going to subtract 4 from both sides. I get 3x equals -4. I'm going to divide by 3 on both sides, and that's going to give me x equals -4/3, which pretty much tells me x cannot be equal to -4/3, because that would make that denominator 0, and that would be illegal mathematically, wrong. Does that make sense? So, what is the domain then? And then I'll answer your question. What is the domain? Well, when in doubt, and you want to sit there and write an interval notation, because they love interval notation on your Hawk system stuff. They love interval notation on the final exam. Therefore, I'm going to love interval notation on your test. So, to get interval notation, draw your number line. Omit the problem points. It's at 0, and in order, it's at -4/3. You've got to omit these guys. But the domain would be anybody else. In English, we would say the answer is all real numbers except 0 and -4/3. But in interval notation, it would be -infinity to -4/3. To omit something, what do I have to use? Parentheses, union, pick it up again, -4/3, you're skipping over -4/3, all the way up to 0, but now I have to skip over 0 again, so I use another parenthesis, union to add to the next interval, 0 to infinity. So use open parentheses to omit something or other. A bracket means include, a parenthesis means exclude. Question?
Yes, couldn't you just use the denominator with the eliminated along with the one you had?
Yes, and that's traditionally what we do. The denominator that I eliminated with the denominator that I have left after I cleaned it up, and set those two equal to 0. But what you really should be doing, and that's typically what happens, but what you really should be doing is looking at the original problem and then all the algebra moves you made to see if anybody else shows up in the denominator that eventually may have canceled or not canceled, don't care. If he's ever in the denominator, I gotta set that equal to 0 and omit that from the, for the domain restrictions. Does that make sense? All right, questions? Yeah, yes ma'am.
For you to get the final answer, I think that the 2 was in 4, but I don't get why you put it on the outside in the answer.
Right here?
Yes.
Because we're multiplying. And this is a parentheses here. So I got two options. I can take that 2, because you're multiplying this numerator by this new numerator. I can either distribute and get 4 minus 6x, or I could leave it in factored form. And because it's a constant, it just mathematically looks better to put the constant in the front instead of sticking them in the back. It's just honestly, both answers are correct. How are they going to have a multiple choice test? They would have put the constant in the front, because that's just standard format. Yeah. You can. Why or why not? Well, let me explain why. Typically, the answers look better if you leave them in factored form. And then the reason for that is this. What if this was a 4, let's see here, 4 plus 3 halves x, making up. So if this is 4 plus 3 halves x times that 2, excuse me, it's gonna be, let me rewrite that. It's gonna be 2 plus 3 halves x. Let's assume it was 2 plus 3 halves x. And with that 2 being on the outside. I mean, okay, so with that, they don't look like they're the same thing. But once you distribute, they are gonna be the same, because it'll be 4 plus 3 halves times 2. The 2's cancel, you get 3x, and they're the same thing. So that part would have canceled, and I could have cleaned it up even further. So traditionally, you try to factor both the numerator and the denominator to see if there's any other terms that are going to cancel. That's why I left it in factored form, because you can now see there are no other terms in common that would have factored. This has got to be the final answer. Other questions? All right. And this one is a little typo there on the equal. So now we got solving rational expressions. And I want you to see the difference between this complex stuff and this solving rational expressions. The big difference is one huge difference. That has an equal to in the problem. This never actually had an equal to except when I started cleaning up and I said that's equal to that, which is equal to that, and we're simplifying it. At the end of the day, you see this problem right here? It says solve. The answer is going to be, in this case, and there's a z, I got typos all over the place. In this problem, I want z equals 45. I circle the answer and I'm done. There's my solution. This is going to have a solution. This was simplify. This was solve. And you do something completely different between simplifying something and solving it. When I have fractions and I want to simplify it, I'm going to go for the common denominator and write my answer over that common denominator. When I'm saying solve, I'm not going to get a common denominator with all the terms. I'm going to try to get rid of the common denominator by completely clearing out denominators. I'm allowed to do that with equations, but I'm not allowed to do that with expressions that I'm trying to simplify. So when I have an equation, we want to, quote, get rid of the denominators so we can solve. So here's my original problem. Let's rewrite this. It is z divided by z minus 1 plus 2 divided by z minus 3 equals z squared divided by z squared minus 4z plus 3. The first thing I'm going to do is, you see the quadratic part? I'm going to factor it so I can analyze what the common denominator would be of all the different terms. So this would be z divided by z minus 1 plus 2 divided by z minus 3 equals z squared divided by, what have I got here? Z, how does this denominator going to factor? Z squared is going to be z and z. What times what is 3? That adds up to be 4. Only one thing to factor is 3. It's 3 and 1. Because it's a plus, they got to have the same sign, and the sign's got to be both minuses. Does that make sense? Did I lose you anywhere? All right. So, all I did was take my original problem and factored the denominator. So now I'm going to find what the common denominator, my least common denominator is going to be. Look at all three of these fractions and tell me what is the least common denominator. Well, to have the least common denominator, I got to have a z minus 1 factor into it. I got to have a z minus 3 factor into it, and whatever extra factor this guy has. But the z minus 3 is already there. The z minus 1 is already there. So this is the common denominator. But what am I going to do with this common denominator? I'm not going to try to get one big fraction out of this thing. That's when I simplify. When I'm solving, I want to get rid of fractions. No one likes fractions. No one likes these numbers over number stuff. So, but the beauty of equations is you can always get rid of the denominator. How do I get rid of the denominator? I'm going to take my entire equation and multiply by my common denominator, z minus 1 times z minus 3. Remember, what I do to one side, I do to the other. What I do to one term, I do to all terms. That's algebra. So I'm going to multiply each one of these terms times z minus 1 times z minus 3. Z minus 1 times z minus 3. And watch what happens when I multiply by my common denominator on an equation. It gets rid of all my fractions. Well, here I got z divided by z minus 1 multiplied by z minus 1 times z minus 3. The z minus 1's cancel, leaving me with the z in the numerator times the z minus 3 plus 2 divided by z minus 3 multiplied times the common denominator z minus 1 times z minus 3. The z minus 3's cancel. I'm left with 2 times z minus 1 equals And now I've got z squared divided by z minus 1 times z minus 3. But when I multiply by z minus 1 times z minus 3, the z minus 1s and z minus 3's cancel, and I'm left with z squared, which means I have no more fractions left over. Does that make sense? Now, here we go. Now we want to solve. To be able to solve, you want to combine like terms. I'm going to distribute so I can collect like terms. What is z times z? Z squared. Z times minus 3 is minus 3z. Distribute the 2. 2 times z is 2z. And 2 times a minus 1 is a minus 2 equals z squared. All right, combining like terms here. I have z squared minus 3z plus 2z is how much? Negative 1z. Minus 3 plus 2 is negative 1. They both have z's on them, so it's minus 1z. Minus 2 equals z squared. It's a quadratic. Well, in this form, it's a quadratic. But how do you solve a quadratic? You always set it equal to what first? 0. So to set it equal to 0, I'm going to subtract z squared from both sides, and it cancels on the left, and lo and behold, it also cancels on the right, leaving me with what? Negative z minus 2 equals 0. Solve for z. I'm going to add 2 to both sides. This will cancel. That gives me negative z equals a positive 2. And then what am I going to do to solve for z? Divide by negative 1. And I get z equals negative 2. But you're not done. Okay? You're not done because you have to go back and look at the problem, and you got to kind of basically check your answer. You're not checking to make sure your math was all right, which is always a good idea. You should always do that. But I'm checking for something special. I'm going to make sure my answer is not one of my domain restrictions. You always got to compare your answer when you're dealing with fractions to the domain restrictions. What are my domain restrictions? Look at this original problem before I butchered it here, and tell me what the domain restrictions are, please. Z cannot be equal to what number? 1. And z cannot be equal to 3. So, what was my z answer? So this is the answer. Listen up. If I did all this beautiful work and I said that z was equal to 3, but z equals 3 is actually one of my domain restrictions, which means z can't be equal to 3, what would my answer been for this problem? No solution. If your answer is a domain restriction, you have to omit it. And if you omit the answer, there are no more answers, there would be no solution. If I had like 2 answers, z equals negative 2 and z equals 1, z equal 1 would not work because it's a domain restriction. I would put a line through it and call it extraneous solution and only circle the one answer, z equals negative 2. You have to check it. Does that make sense? Yes? Both, actually. Yeah, but if you remember, on the right side of the equals, it was z minus 1 and z minus 3. So when you set both of those equal to 0, you get the same thing. Z is 1 and z is 3. You use both sides. There will be more restrictions, exactly. Other questions? Okay. Last section is section 2.6. Radical equations. So, what is a radical equation? That's an equation with either 1 or 2 radicals in it, and what we're going to do with this stuff. Okay, so remember this. When it comes to rational, what's a fractional equations, you have to check your answers at the end and making sure you're not violated one of your domain restrictions. That's why the domain restrictions are so important. The other type is this, radical equations. These are equations with radicals. They could be square roots, they could be cube roots, they could be stuff to fractional powers like 2/3 or whatever. These are all considered radical equations because remember, a fractional exponent is the same thing as a radical. A 1/3 power is a cube root. A 1/2 power is a square root, right? So here's the deal. Here's an equation. Square root of 2x plus 15 minus 6 equals x. I want to solve for x. I win the game when I get x equals. But the only way I'm going to be able to get x equals is I got to get rid of my radical. That is a square root. What gets rid of a square root? Squaring it, doing the opposite. But the problem is when it comes to radicals, you have to do it two sides of equations. You're talking about powering things up. So if I'm going to power it up with a square root, I want to square it. If it was a cube root, I want to cube it, so forth and so on. But what I do to one side of an equation, I have to do to the other. What I do to one radical, what I do to one side, I have to do to the other side. That's the trick on this thing. So step one, when solving a radical equation, is get the radical by itself. So what's my first move on this problem? Add 6. Get the radical by itself. That's going to give me the square root of 2x plus 15 equals x plus 6. Does that make sense? Now you got the radical by itself, you want to get rid of the radical. What gets rid of radicals? Well, this is a square root, so what gets rid of a square root? Squaring it. And what I do to one side, I do to the other. So I'm going to square both sides. And you do it to sides. You don't do it to terms because it's powers. You have to do it to both sides. Okay? And remember this, when it comes to powers, you only get to distribute powers through strict multiplication division. I got a big problem with this one. That's a big old plus right in the middle of that x and 6. That's not multiplying division. So you can't distribute powers. So clean this guy up. Let me show you. The square and the square root cancel. That was the whole purpose. That leaves me with 2x plus 15 equals, and I've got x plus 6 squared. Now I want to focus on this x plus 6 squared. Right here is where most students are going to screw this problem up and get the wrong answer. Because they're going to try to distribute the 2, the square. You know, x plus 6 squared is x squared plus 6 squared, which is 36. And they put x squared plus 36. And they screwed it up. Because you can't distribute powers unless it's strict multiplication division. Strict multiplication division, you get to distribute powers. That's not strict multiplication division. That's addition. So the only way to clean up adding or subtracting between terms and you're powering it up is to do your favorite FOIL method. You've got to FOIL it out. So, because what does x plus 6 squared really mean? It means 2x plus 15 actually equals x plus 6 times x plus 6. That is what squared means. And how do you clean up x plus 6 times x plus 6? FOIL it out. X times x is x squared. X times 6 is plus 6x. 6 times x is another 6x. And 6 times 6 is plus 36. That leaves you with 2x plus 15 equals x squared plus 12x plus 36. So, all this work, what did your problem just turn into? A quadratic, because I got a big old x squared now in this thing. How do you solve a quadratic? You've got to first set them equal to your favorite number, which is 0. So my next move is I'm going to subtract 2x from both sides, and I'm going to subtract 15 from both sides. This cancels, leave me with 0 equals x squared. What is 12x minus 2x? Plus 10x. And what is 36 minus 15? Plus 21. So I'm going to write my answer. Take this over here because I'm running out of room now. That gives me x squared plus 10x plus 21 equals 0. All right. You have got 3 different ways of solving a quadratic. You've got 1, you could factor it. 2, you could use the quadratic formula. Or 3, you could use complete the square method. All right? Question for you. Do you see a gun in this problem anywhere? Nope, I don't see the words use complete the square method to actually beat this thing up. I don't see that, and I'm not going to do that to you guys. Okay? I will give you like one problem solved by completing the square just because I want to see your work on completing the square. But I didn't put that in this problem. This one is just get the answer. So if I'm just going for the answer, I'm either going to try to factor it or quadratic formula. I'll try to factor it first. If I can't get it to factor in less than, a minute, then I will use the quadratic formula. But I believe I can factor this guy. How does this guy going to factor? Very good. I got x squared, which is x and x. What times what is 21 that adds up to be 10? 7 and 3. And because both signs are plus, the terms in the middle have to be pluses. So I then, quadratic, I set each factor equal to 0, and I solve. I get x equals -7. I get x equals -3. I subtract 7 from both sides, I subtract 3 from both sides. Does that make sense? But you're not done. Just like in the domain restrictions of the last problem with fractions, you got a very similar problem when it comes to radical equations. You have to check your answers. Because of you doing so much algebra, squaring both sides, pulling things together and stuff like that, there you can get, quote, extraneous solutions. Solutions that you did every math part right and they still don't work. So you have to check your answers. So I'm going to come over here, I'm going to check my answers. And I'm not just checking to make sure they're right, I'm checking to make sure I didn't violate a rule of math. Because all of my math is good. So here we go, check. I'm going to check x equals -7. And what I'm going to do here is go back to the original equation and plug in my answer and see if it works. This will be the square root of 2 times -7 plus 15. I'm going to subtract 6 and see if that equals -7. Well, what's 2 times -7? -14 plus 15, 1. So this is the square root of 1 minus 6. Does that equal -7? What's the square root of 1? Minus 6. Does -5 equal -7? No. This is not a solution. That is an extraneous solution. I did all the work right, but still got the wrong answer on it. All right? So that one didn't work because it was an extraneous solution. Now I got to check the other guy. What was my other guy? X equals what? -3? Plug it in. This would be the square root of 2 times -3 plus 15, subtract 6. Will that be equal to -3? Is the question mark. And I put a little question over there because I'm checking it. Well, what is 2 times -3? -6 plus 15. -6 plus 15, 9. So this is the square root of 9 minus 6. Does that equal -3? What's the square root of 9? 3 minus 6? -3. Does -3 equal -3? That checks. This is my answer. Does that make sense? And it's the only answer. So let me explain this in direct terms. They love to give you this kind of a problem on the old cumulative final exam. And they're going to be a multiple choice question on this one. And they're going to go A. The answer is -7 and -3. B. The answer is -7. C. The answer is -3. D. The answer is 14. Or E. The answer is 275. Or E. I'm going to try this class again next semester. I don't know. Like A, B, C, D, E, whatever you got. You understand? What I'm trying to tell you is this. They're going to try to mess you up because you know how many people, because they do all this stuff, they see these two answers, and they're going to bubble in. The answer is -7 and -3. And they did a beautiful problem, did all the work right except for one little small move, and they're going to get 0 points for it. Because what is the real answer? Just -3. Don't forget, with radical equations, you have to check your answers because they don't always work because of all the manipulation of the algebra that you do. Does that make sense? All right. Solving equations with two radicals. Well, this one is the famous, I got the cube root of 3x plus 2 equals the cube root of x minus 1. Well, this one's nice because here's the deal. You want to get the radical by itself, okay? You want to get the radical by itself. So, let's do this. They've already I got two of them. Well, how do I get them by himself? Well, you put one on one side and put the other dude on the other side, okay? You want to separate your radicals. Now, what gets rid of a cube root? What gets rid of a square root with square? What's going to get rid of that cube root? cube, so I get to do what I do to one side, I do the other. So this is the cube root of 3x plus 2, and I'm going to cube it, and that's equal to the cube root of x minus 1, and I'm going to cube it. I'm going to cube both sides. Does that make sense? All right? Now, the cube root and cube cancel, so I'm left with 3x plus 2 equals the cube root and cube cancel, I'm left with x minus 1. Does that make sense? Cube roots and cubes cancel. Now I'm going to solve. I'm going to subtract x from both sides. That gives me 2x plus 2 equals negative 1. I'm going to subtract 2 from both sides. That's going to give me, let's see here, 2x is equal to minus 1 minus 2 is a negative 3. And then I'm going to divide by 2 on both sides, and that gives me x is equal to negative 3 halves. Does that make sense? Now, what do I have to do to this thing? Check it. So, does the cube root of 3 times negative 3 halves plus 2, does that equal the same thing as the cube root of negative 3 halves minus 1? Well, let's see. 3 times negative 3 halves is a negative 9 halves plus 2. Does that equal to the cube root of negative 3 halves minus 1? All right. Common denominator here. I got negative 9 halves plus 2. 2 is the same thing as 2 over 1, but I want a common denominator of 2. So 2 is the same thing as 4 over 2. Agreed? And negative 9 halves plus 4 halves. Negative 9 plus 4 is negative 5 halves. Does that make sense? Does that equal, question mark, the cube root of negative 3 halves minus 1? But minus 1, I need to have a common denominator. I'm going to make that 2 over 2. So, does the cube root of negative 5 halves, does that equal negative 3 halves minus 2 halves? Well, what's minus 3 minus 2? Minus 5 halves. And it checks. They're the same thing. Now, let me stop here for just a second while people are staring at this thing going, I feel like there's something wrong with this problem. There's a negative underneath a radical. Yeah, but what kind of radical is it? Cube root or odd root. You're allowed to take the odd roots of negative numbers, just not even roots of negative numbers. Can't take the square root of a negative number or the fourth root of a negative number, but odd roots are okay. This thing worked. I got the same thing on both sides. All right. Let's see if we can make it more difficult for you. Try this guy. I've got the square root of x plus 5 minus the square root of x minus 3 equals 2. Okay? Solve for x. This is another one of those double radical guys. What to solve when you have multiple radicals in a problem is this. Get one of your radicals on one side by himself and move the other radical to the other side. So which one do I want to get by himself? Well, which one's the easiest one to get by itself? The square root of x plus 5. So I'm going to move the other radical to the other side by adding the square root of x minus 3 to both sides. This is going to give me, this will cancel, this is going to give me the square root of x plus 5 equals 2 plus the square root of x minus 3. I just move one of my radicals to the other side. Now be careful on this one because there is the careless error aspect on this. Be careful. Now, I got one of my square roots by himself. What kills off a square root so I can get rid of that radical? Square it. But remember, when it comes to powers, what you do to one side of an equation, you do to the other. I'm going to square both sides. The square and the square root cancel. What am I left with over here? X plus 5. And that's going to be equal to parentheses 2 plus the square root of x minus 3 quantity squared. But just like in that first problem that I did, I need to clean this guy up. And I can't distribute a power through addition or subtraction. Does that make sense? See, in the last problem, I didn't have addition or subtraction. I just cubed both sides, but this thing was by himself, so the cube and the cube root end up canceling on both sides. But on this side, it won't. So What does square really mean? Multiply by himself. So this is x plus 5 equals 2 plus the square root of x minus 3 times 2 plus the square root of x minus 3. And how would you clean up terms that are being added or subtracted, quantity squared? We're going to do like we always did. We're going to full it out. Let's full this out. So x plus 5 is going to be equal to, what is 2 times 2? 4. What is 2 square roots of x plus 3? They're not like terms, you just put them together. It'd be 2 square roots of x minus 3. What is square root of x minus 3 times 2? And that's another plus 2 square root of x minus 3. And here comes the last. What is square root of x minus 3 times another square root of x minus 3? Yeah, because square root times himself means he's squared, so they cancel, then you just get x minus 3. Square root of x minus 3 times the square root of x minus 3 is x minus 3. Does that make sense? Let's clean this stuff up. So I'm left with x plus 5 is equal to, what is 4 minus 3? Combine my terms. 1. Plus x, and then I'm going to put the radical together. What is 2 square roots of x plus x minus 3 plus 2 square roots of x minus 3? Very good. Plus 4 square roots of x minus 3. When they're like terms, you just add the numbers and their coefficients up front. Awesome. All this work, but I have made progress. This original problem was a 2 square rooter problem, and I've just beat it to death to turn it into a 1 square rooter problem. But that's making progress. So now what am I going to do? Well, anytime you got a square root in the problem, get him by himself, move everything else to the side, and what gets rid of a square root? Square both sides. You want to square both sides again. But first, get the square root by himself. So I'm going to subtract 1 from both sides and subtract x from both sides. The x's end up canceling. The 1's cancel. What is 5 minus 1? 4 equals 4 square root of x minus 3. And wait a minute, remember I said get the square root by himself. You don't want any coefficients in front of this thing. So how are you going to get rid of that times 4 in front of that square root? Divide by 4 on both sides. Moving it this way because I got more room. This is going to give you 4 divided by 4 is 1 is equal to, 4's cancel, square root of x minus 3. Now, got that square root by himself. What am I going to do so I can solve for x? Square both sides. 1 squared, that's pretty much 1. I can do that without having to fold anything out here. And what's the square root of x minus 3 squared? X minus 3. Now solve for x. What am I going to do? Add 3 to both sides. This cancels. So what's x equal to? 4. I got a question for you. Are you done? Nope, it's a square root kind of a problem. Any kind of radical kind of a problem, you want to, quote, check your answer. So I got x equals 4. So go back and do the check and plug it into the original equation. The square root of 4 plus 5 minus the square root of 4 minus 3, will that actually equal 2? This is my check. So, what's 4 plus 5? Square root of 9 minus, what's 4 minus 3? Square root of 1. Does that equal 2? Square root of 9 is 3. Square root of 1 is 1. 3 minus 1, does that equal 2? Yes, it does. So it checks. So this is the correct answer. X equals 4. If this did not work, we would say the answer is no solution. And on your Hawk system, what's the symbol for no solution? The circle with a line through it, the empty set. Does that make sense? All right. What about rational exponent equations, which are still more radicals? I have 8x raised to the 5/3 power, and that's representing 5/3 power minus 24. When you're solving radical equations, when you're solving equations that have fractional, rational exponents, get the term with the variable by itself. So what's my first move on this problem? Add 24. to both sides. This is going to give me 8x raised to the 5/3 power equals 24. Now, I want to get rid of my power. When I had a square root, what got rid of a square root? Squaring it. When it was a cube root, what got rid of a cube root? Cubing it. What gets rid of a 5/3 power? What I really want is to have a power raised to the first power. Anything to raise to the first power is themselves. So I want to get rid of this power. But remember, what I do to one side, I do to the other. So what's going to get rid of a 5/3 power? Raising it to the 3/5 power. The inverse of that power. Why? Because power to a power, what do I get to do with the powers? Multiply. And the 5's cancel and the 3's cancel. That's to the first power. But what I do to one side, I do to the other. So this will cancel, leaving me with 8x is equal to 24 to the 3/5 power. Now let me remind you of something, Roe. Something we did from the first few days we were in this class. When I have m raised to the p over q, when you have some number raised to a fractional power, what this really means is this. It is the cube root of m to the p power. And you can do it either way. You can write a cube root of m to the p power, or you can write the cube root of m all raised to the p power. It's your choice which way you want to use this guy. But it's the same thing. So I want to clean up 24 to the 3/5 power. 24 to the 3/5 power is the same thing as the 5th root of 24 cubed. Does that make sense? And again, I decided to write it this way, but I could have written it either way. I want to clean this guy up. How do I clean up a radical? Break him down. All right. What exactly is 24? Prime factorization. This is the 5th root of, let's see here, 24. 24 is what? 24 is 6 times 4, right? 6 times 4, I'll write them like that for your benefit. Cubed. It doesn't matter which factor you use because you want to break it down even more. What's 6? 3 times 2, what's 4? 2 times 2. Cubed. Does that make sense? I want to clean this guy up. And remember, I could have written it either way. It's a 5th root. I don't have any 5th guys in here, so I could put that 5th root of 3 times 2 times 2 times 2 cubed. What does cube mean? Powering up 3 times, right? So this is the 5th root of 3 times 2 times 2 times 2, 3 times 2 times 2 times 2, and 3 times 2 times 2 times 2. But it's a 5th root. For every 5 things, we get to do what? Pull one thing out. So do I have any, do I have 5 things of anything? Sure. Let's see here. There's 3 and there's 2 more 2s. So for those 5 2s, I get to pull one out. What do I have any more? Let's see here. I got 1, 2, 3, 4 2s. Nope. I'm left with the 5th root of 3 times 3 times 3, 3 3s, and I'm left with how many 2s? 1, 2, 3, 4 2s. 2 times 2 times 2 times 2. Because of that 5th root, I don't have enough stuff. But I can put him back together again as a number. Let's see here. 3 times 3 times 3. 27. 2 times 2 times 2 times 2. 16. So 27 times 16 is 432. So this is 2 times the 5th root of 432. Just happens to be what it is. So I've got 8x is equal to 2 times the 5th root of 432, and this guy doesn't break up. But now you're at the goal line. How are you going to solve for x? Divide by 8. And clean it up. So x is going to be equal to 2 goes to 8 how many times? 4 times. So this is the 5th root of 432 over 4. Now, you could put this on your calculator and get some kind of decimal answer, and a lot of the times on the system, the homework, web work system, it will actually take the decimal answer, but I want you guys to have the ability to actually do the radicals, because this review's cover that chapter 1 stuff we did. Does that make sense? So let's do another one of these problems. Try this one. X plus 5 to the 3 halves equals 8. Oh, yes, ma'am. Question. Yes. On this kind of a problem, I would want you to put it as a radical. Clean up the radical. Well, it depends. If I say write it as a radical, yeah. If I say write it as a decimal, no. If I say just solve the answer, I don't care how, then I'll take either one. But if the directions tell me write it as a radical, leave it in radical form. All right, what about this one right here? I got x plus 5 raised to the 3 halves power equals 8. What are you going to do? First, get the variable with the power by himself, which it already is. So I've got x plus 5 raised to the 3 halves power equals 8. What's going to get rid of these fractional 3 halves power? What am I going to do? Raise it to the what power? 2/3. What I do to one side, I do to the other. So it's the reciprocal of that power, and raise both sides. What I do to one side, I do to the other. This cancels. This leaves you with x plus 5 is equal to 8 to the 2/3 power. Let's talk about that. What is 8 to the 2/3 power, also known as? Cube root of 8 squared. Right? But do you guys happen to know what the cube root of 8 is? What times what is 8? 2. This one works nice. 2. Cube root of 8 is 2, but then you're supposed to do what? Squared. So what's 2 squared? 4. So this cleans up to be 4. And for those people that just don't trust themselves, well, check your calculator out. 8. To raise it to a power, you got the little caret symbol right there. Raised to the, what power is it? 2/3 power? And you bet, it's 4. But now, so I've got this. X plus 5 equals 4. And then what's the last move you're going to make? Subtract 5 from both sides. And that leaves you with x equals -1. And of course, you can go back and check your answer. I could have checked this one too by plugging it in, but that really will require a calculator here. So this one, what is -1 plus 5? 4. And what is 4 raised to the 3 halves power? So I'm checking my answer. I got 8, so it checks. This is my answer. Does that make sense? All right, let's try this next problem here. X minus 1 to the 2/3 power is equal to 7 minus x raised to the 1/3 power. All right? Now, here's the deal about this one. I've got rational fractional exponents on both these two guys. But you'll notice something very important. They both have the same denominator in terms of your fractional power. What denominator is that? 3. So remember, a 2/3 power, this is squaring this thing and then taking the cube root of it. A 1/3 power is cube rooting it. What gets rid of a 1/3 power or a cube root? Cubing it. So you want to raise it to whatever the denominator is. So because I have two problems that have fractional exponents, I want to raise it to the common denominator. That's what I'm doing with the powers. So I'm going to get x minus 1 to the 2/3 equals 7 minus x to the 1/3 power. Okay? And I'm going to raise both sides to the 3rd power. Just a cube. I'm not trying to get rid of the 2/3 power or anything like that. I just want to do to the 3rd power. You're going to see why in a second. Power to a power, I multiply. So this part cancels. I'm left with x minus 1 squared is equal to, the 3's cancel, and anything to the 1st power is himself. Does that make sense? Officially, this is to the 1st power, but no reason to write 1st powers. How do I solve this? So I've got rid of my cube roots or my 3rd powers on this thing. Well, I want to clean this guy up. It's squared. How do you clean up x minus 1 squared? You're going to FOIL it out. This is gonna be same thing as x minus 1 times x minus 1 equals 7 minus x. Pulling it out, x times x is x squared minus x minus another x plus 1 equals 7 minus x. This is x squared minus 2x plus 1 equals 7 minus x. Does that make sense? It just turned into a quadratic. How do you solve a quadratic? First thing you're going to do is set it equal to your favorite number. What's your favorite number? 0. So I'm going to subtract 7 on both sides, and I'm going to add x on both sides. And combining like terms, this is going to give me x squared. Minus 2x plus x is minus x. Plus 1 minus 7 is minus 6 equals, all this stuff canceled, that's 0. And you hope and pray it factors. If it doesn't factor, you always have the quadratic formula. But this one does factor. How does x squared minus x minus 6 factor? X minus 3, x plus 2. Set each factor equal to 0 and solve. X equals 3 and x equals negative 2. Are you done? No. What's the last thing you need to do? Check it. And on this kind of a problem with these fractional powers, I'm going to use the power of the calculator to check it. Let me show you. I'm going to plug it in, checking these answers. Here we go. I get 3 minus 1 to the 2/3 power is equal to 7 minus 3 to the 1/3 power. And I'm going to check that out by typing it in on my calculator and see if they're both the same thing on both sides. 3 minus 1, I can do that kind of math, that's like 2, raised to the 2/3 power, and I get some crappy number, 1.587401052. And what does that equal to? Parentheses, 7 minus 3 raised to the 1/3 power. Do I get the same number? 1.587401052. It checks. So this one is a winner. So what am I going to do now? Take this guy and plug him in. This would be checking, plugging in x is negative 2. Negative 2 minus 1 to the 2/3 power. Does that equal to 7 minus negative 2 to the 1/3 power? And I'm going to again check it on my calculator. Parentheses, negative 2 minus 1 raised to the 2/3 power. And I get 2.080083 something or other. And I'm going to check the other side. Parentheses, 7 minus negative 2 raised to the 1/3 power. Oops, screwed that up here. 1/3 power. And do I get the same thing? 2.08008. They check. So this problem has 2 solutions. Does that make sense? Now, the last one, very quickly, because it's a short problem, but here's the deal. I've got x to the 2/3 power minus x to the 1/3 power minus 2. These are what we call quadratic wannabes. It looks kind of like a quadratic. Let me show you. This is x to the 1/3 power squared minus x to the 1/3 power minus 2 equals 0. Because power to a power we multiply. 1/3 times 2 is 2/3. So if I did this, let u equal x to the 1/3 power. I want to show you. I'm going to let u equal x to the 1/3 power. But you must understand, x to the 2/3 power is actually x to the 1/3 power quantity squared. Because a power to a power we multiply. This turns into u squared minus u minus 2 equals 0. If I gave you this problem on the test, could you do it? U squared minus u minus 2 equals 0. How would you solve it? Factoring it? How would it factor? U, what times what is 2? 2 and 1. To add that, subtract up to be negative 1. That means it's got to be a minus on the 2 and a plus on the 1. So I'm going to set each factor equal to 0. And I'm going to solve. U equals 2 and u equals negative 1. But that wasn't the question. The question was x. So go back and back substitute. What was x equal to? What was u equal to? X to the 1/3 power equals 2, and x to the 1/3 power equals negative 1. What gets rid of a 1/3 power? Cubing it, raising it to the 3rd power. Does that make sense? So I'm gonna, one last step, once you back substitute, is raise both sides to the third power. Now this cancels, I'm left with x equals, what's 2 cubed? What's 2 times 2 times 2? 8. And over here, the 1/3 and 3 power cancels, I'm left with x equals, what's negative 1 cubed? What's negative 1 times negative 1 times negative 1? Negative 1. And there are my two solutions. And the last thing you can do is check them. And again, checking them on the calculator, 8 to the 2/3 power minus 8 to the 1/3 power minus 2. If I plug an 8 into this thing, what should it be equal to? Do I get 0? Yes, I do. You can see it better right there. Yes, I do. I get 0. And then plug in the last one, negative 1 to the 2/3 power, power 2/3, minus parentheses negative 1 to the 1/3 power, minus 2. When I plug in negative 1 into this thing, do I get 0? Yes, I do. So both these two answers check. Study this stuff, but I'm telling you honestly, go over my homework set that I made up for you guys, and with the bonus questions, because I left off some quadratic parts because last page didn't print. And if you guys can focus and do that work, you should do real well on my test. It is due by Friday at 12:30. And bring it here if you can to the review session, Friday at 12:30. See you guys then.